Welcome class. Thank you for joining me for our second day of dividing polynomials. So remember yesterday we focused on log division. Now today we're going to focus on the second type called synthetic division. Now personally synthetic division is by far my favorite. I love synthetic division. However, there's one stipulation. The reason we didn't show you this in Expo, and the reason this is the secondary method we're showing you today, is because it only works in certain cases. Okay? The only time that this works is when you're dividing by a linear binomial where the variable has no coefficient. So talking about x plus 3, x minus 4, x plus 5, x minus 2. It always has to be in that form, okay? It always has to be x by itself plus or minus a number. It's the only way we can use this synthetic division, unfortunately. However, when you can use it, students typically find it much, much easier, okay? Now, this next piece of your notes, this is just to show you the step-by-step process, okay? I'm not going to talk over this, and you don't really have to look at it closely right now. Just after taking these notes, if you need to reflect on why I did anything I did, what the setup looks like, anything of that sort, this is where you can come to see exactly how it's supposed to look, all right? But to really start this process, I'm going to jump down and I'm just going to dive into our first example. Now, to set this up, the first thing that we're going to do is we're going to look at the term right here, x minus 5. And what you always have to do is start with the opposite of the number that you see there. So instead of putting a negative 5, I put in a 5. Now, once you've done that, you are going to take every coefficient that you see in the polynomial. So 1, negative 8, 17, and negative 10. You're just going to take those coefficients and you are going to line them up. Okay, just like that. Now, once you've lined them up, you have the setup that you need for this synthetic division. Once you have that lineup, you're going to begin just by dragging down that first number. All right, the first number is always just going to be dragged straight down. Whenever you have a number there, you are going to multiply it by the number in that box. So I'm going to take that 1 and I'm going to multiply it by the 5. And whenever you do that, that goes in the next spot right there. Whenever you have two numbers vertically like that, now I'm just going to add them. Negative 8 plus 5 gives me a negative 3. And remember what I just said. Whenever I have a number down there, I'm going to multiply it by that number in the box. So I'm going to take that negative 3, multiply it by the 5. And that's going to come over here. Now, again, whenever I have two numbers vertically like that, now I'm simply going to add them. 17 plus negative 15 gives me a 2. Oh, well, I've got a number down there again. So when I have a number down there, remember, I multiply it by the number in my box. So I take 2 times that 5. That's going to give me a 10 right there. And now, whenever you have two numbers vertically, now you're going to add them. Okay, now notice I am out of numbers now. Okay, I'm at the end of my line. So what I'm going to do is I always offset that number right there because that number is special. That number actually represents the remainder. Now, in this case, notice my remainder is 0. So I don't even actually have to worry about the remainder at this moment. But now, working right to left, The first number you encounter is your constant. The second number you encounter is going to be your x. The third number you encounter is going to be your x squared. If there were another number, that would be your x cubed, even though we don't have one, so on and so forth. Okay? So just like when we started the problem, each of those numbers was a coefficient of the polynomial. Well, that's actually the same case here. So what is this telling me? Well, it's telling me my answer is x squared minus 3x with a constant of 2, and that there is absolutely no remainder. So that's what synthetic division looks like. Now, again, personally, I find it a really fun process. I find it a lot easier than long division. You just have to remember the setup, how to go about doing it. But once you know how to do it, it's actually super simple to be able to replicate and do again. And the cool thing is there's absolutely zero tricks to it. There's nothing that can make it any harder. So let's do another example, okay? Now, this is showing you that there is another commonality with long division. If a term is missing, it is very, very important that you leave a 0 in its place. If you don't, it's going to throw off your your synthetic division process. Okay? But first, to set up for synthetic division, I looked at x minus 1, and I'm going to put the opposite of that number up there. And I'm going to line up the coefficients. 1, x to the 4, 2, x cubed, 0, x squareds, I need it there to hold its spot, 1x, and then negative 3. So once I have my coefficients lined up, now I'm ready. So remember, the first step in our process is to pull down the 1. Whenever I have a number down there, I multiply it by the number in my box. So 1 times 1 is 1. And now I have two numbers vertically stacked. Remember, that means I add. 2 plus 1 is 3. All right, well, now I have a number down there. That means I'm going to end up multiplying. 3 times 1 gives me 3. Oh, I have two numbers vertically stacked. 0 plus 3 gives me 3. Have a number down there again. So now I multiply. 3 times 1 gives me 3. Okay? Have two numbers stacked on top of each other. So I add and get 4. All right, I have a number down there. So I multiply. 1 times 4 is 4. I have two numbers stacked vertically. Negative 3 plus 4 gives me a 1. Now notice I'm at the end of my process. So I'm going to offset that last number, because remember, that last number is special. That last number is the remainder. And now, to make sure that I understand what each of these numbers represents, I'm going to start left or right to left. So that's my constant, my x term, my x squared term, and my x cubed term. Because to actually answer this question, I really need to write out the full answer. So this is telling me that my full answer is x cubed plus 3x squared plus 3x plus 4 and a remainder of 1. And remember, the remainder goes over whatever you were dividing by. And that's going to be your answer. All right, so let's continue on. So if the polynomial x cubed plus 6x squared plus 11x plus 6 expresses a volume in cubic inches of a box, and the width is x plus 1 inches, what are the dimensions of the box? All right, So we need to think about a plan. To tackle word problems, we always want a plan. So first of all, how does the volume of a box relate to its dimensions? Well, isn't volume length times width times height? So if I want the other two dimensions of the box, wouldn't I end up just dividing by the width, and that'll give me the other two dimensions? So this is really setting up a division problem. I'm taking that x cubed plus 6x squared plus 11x plus 6, and I'm dividing it by x plus 1. And the cool thing is, we can use synthetic division to do that. So we're going to start by looking at what we're dividing by, that x plus 1. Well, that means the opposite goes in my little box there. Now I line up all the coefficients. 1x cubed plus 6x squared plus 11x plus 6. And now I have my setup for my long division. So I'm going to pull down that first number. Whenever I get a number down there, I'm going to multiply. 1 times negative 1 gives me a negative 1. Whenever I have two numbers vertically stacked, I add. 6 plus negative 1 gives me a 5. Number down there means I multiply. 5 times negative 1 gives me a negative 5. I have two numbers vertically stacked. Now I'm going to add. 11 plus negative 5 gives me 6. Now I multiply. 6 times negative 1 gives me negative 6. Finally, I add, and that ends my process. So what does that mean? Well, that means I have a remainder of 0, constant of 6, 5 x's, and 1x squared. So that means right now, my answer looks like this. All right, so now we have a quadratic left. So if we want all the dimensions here, well, that x squared plus 5x plus 6. If we want all the dimensions, doesn't this factor into x plus 2 and x plus 3? So really, we know the width is x plus 1. Either the length or the height, doesn't matter which one, is x plus 2. And the other is x plus 3. So by using synthetic division, we took that cubic, broke it down into quadratic, which we could then factor to get all of the linear pieces. So that's kind of the cool thing about synthetic division, is you can use it to break down polynomials. So let's move on to the last page. All right, now this remainder theorem seems kind of wordy. So let me just tell you in a nutshell what it means. Really, in a nutshell, all that it means is that if you use the synthetic process on a polynomial, so here, if you're looking to find what is p evaluated at 3, you can actually just use synthetic division to do that. All right, because the remainder from the synthetic division will actually be your polynomial. So 1x to the 5th, no x to the 4ths, negative 2x cubed, negative 1x squared, no x's, and a 2. So I have this set up. So to go through our process, drag down the 1. Now I multiply. 1 times 3 gives me 3. Once I have that, now I add. 0 plus 3 gives me 3. Now I have a number down there, so now I need to multiply. 3 times 3 gives me 9. All right. Now, negative 2 plus 9 gives me 7. Multiply again. 3 times 7 gives me 21. Oh, now I need to add again. Negative 1 plus 21 gives me 20. Need to multiply again. 3 times 20 gives me 60. Now I add. 0 plus 60 stays 60. Now I multiply. 3 times 60 is 180. And now I add to get 182. And now once you've reached the end of this process, what this is telling you is that you've now solved your problem. The 182, that remainder, is the same as if you were to evaluate that function at 3. Okay? Now, even take your calculator for a second. Try it out. It's a neat little trick, a quick way to evaluate these large numbers. Okay? So, just a little tidbit for you that is another use for synthetic division. Now, one more use for synthetic division, another type of word problem that you will come across. 3 consecutive integers have a product of 120. What are the 3 numbers? So, we want to think of a plan. So 3 consecutive integers multiply to 120. So what does that mean? How can I represent 3 consecutive integers? Now what that means is if I have x representing one of my numbers, the next consecutive integer is going to be x plus 1. The next integer would be adding 2 to that. So my 3 consecutive integers can be represented by x, x plus 1, and x plus 2. You're basically just counting, right? So form an equation to represent the product of those numbers. So we want the product of these numbers to be 120. All right, now, synthetic division needs everything in standard form, okay? So to get this in standard form, the first thing I'm going to do is FOIL out those 2 terms right there. So I'm going to have x squared. Now, 1x and 2x makes 3x. 1 times 2 leaves me 2. So once I've FOILed that out, now I can distribute in that x. So currently, that is where we're sitting with our polynomial for solving this problem. Now, it says that we should solve it for 0. So what that means is to get my true polynomial, we want that. And now we're going to be searching for our solution, searching for our root. And we are going to search using synthetic division. Okay? So, we want to know what number will actually solve this. What number is a root of this? And it says we can use synthetic division to try to search for that. So let's see if 1 works. 1, 3, 2, negative 120. Because if 1 is a root to this, it means that it is our solution. So let's take a look. Drag down my first number. Now I multiply 1 times 1. Now I'm going to add. Now I'm going to multiply. 1 times 4 gives me 4. Add 2 plus 4 gives me 6. Multiply 1 times 6. And now subtract. Now, that did not end up working, okay? 1 is not a root, is not a solution to that equation. So that means we have to try again. All right, let's try 2. Let's see if 2 is a solution to our equation here. Pull down my 1. Now I multiply. 1 times 2 is 2. I'm going to add 3 plus 2 is 5. Now I'm going to multiply 2 times 5 gives me 10. 2 times 10 gives me 20. Oh, I'm sorry. That's the adding step. 2 plus 10 gives you 12. Times 2 gives you 24. But that's still not quite what I'm looking for, okay? Still not at 0. Not a solution. So we have to try our next number. So let's see if 3 is a solution. So let's pull down our 1. And now 1 times 3 is 3. 3 plus 3 is 6. 6 times 3 is 18. 2 plus 18 is 20. 20 times 3 is 60. All right, so we're still not quite there yet. However, notice every time we've been getting closer to 0. So it's looking promising. So let's try this one more time. Let's see if it works with 4. One, 3, 2, negative 120. I pull down my 1. 1 times 4 is 4. 3 times 4, or sorry, 3 plus 4 is 7. 4 times 7 is 28. 2 plus 28 is 30. Times 4 is 120. And there we have it. We finally got to our 0. So that means 4 is a solution to this equation. That means 4 is the number we're looking for. So the 3 consecutive integers that multiply to 120 are going to be 4, 5, and 6. So do be aware that that's how you can solve word problems such as this. Now, I apologize that this video got a little bit longer. However, I do thank you for joining me, and please make sure you have all of this written down so you can come back and are ready to do your practice work in class.